Sima claims that n is greater than log to the base 2 of n for n is positive integer. Question A shows that 1 plus log to the base 2 of n is greater or equal than log to the base 2 of n plus 1 for n is positive integer. Let's consider the next expression, everything to the right. Why? Because it's more useful, more easier to compare something with 0. So let's consider log to the base 2 of n plus 1 minus log to the base 2 of n minus 1, and when it shows that it's less or equal than 0. And we can see that 1 it's what? It's log to the base 2 of 2, and hence it can be rewritten as a single log, just using properties for logs. Formulas are given in a data booklet, and difference of two logs to the same basis is just one log of the ratio, so it can be rewritten as log to the base 2 of n plus 1 divided by n, and it's log to the base 2 of 2, so also divided by 2, so over 2n. And let's consider the argument of this log, n plus 1 over 2n, and you can see that n is positive integer. What does it mean? So n can be what? 1, 2, 3, and so on. And you can see that when n is 1, we get 2 over 2, it's 1, and log to the base 2 of 1, it's what? It's 0, because the graph of log looks like this. And when base is greater than 1, it's increasing function. When base is from 0 to 1, it looks like the decreasing function. And when n is greater than 1, for example, when n is 2, you can see it becomes what? 3 over 4, and 3 over 4 is somewhere here between 0 and 1, and you can see that a log has what? Negative value, and for any other value of n, for example 4 or 5 and so on, so for example 4, you can see it's 5 over 8, and you can see that always there will be what? There will be that denominator will be larger than the numerator, and always this expression will be less than 1. And definitely it's positive because n is positive. So we can say that n plus 1 over 2n is less or equal than 1 and is greater than 0, is positive. And hence, for n is positive integer, hence log to the base 2 of n plus 1 over 2n is, and just from a graph you can see that it's what? Less or equal than 0. And therefore log to the base 2 of n plus 1 minus log to the base 2 of n minus 1 is equal to this, and it's less or equal than 0, and hence again it's 1 and log to n to the right, and we get 1 plus log to the base 2 is greater or equal than log to the base 2 of n plus 1 as required. The next question, we use mathematical induction and the result from the part A to prove that Sima's claim is valid. So we should prove that n is greater than log to the base 2 of n. And as usual, the first step is we consider the first possible value of n. Here it's 1. And for n is 1, the left hand side is 1, and the right hand side it's log to the base 2 of 1, and it's 0. Hence, as the left hand side is greater than the right hand side, it's true. For n is 1. Then, as usual, we write assume true. for n is k, and rewrite our statement substituting k for n, so it becomes k is greater than log to the base 2 of k. And then we can see that for n is k plus 1, and we show that it's true for n is k plus 1. So we should get that k plus 1 is greater than log to the base 2 of n k plus 1. So it's our aim at this step. And we can consider this k is greater than log to the base 2 of k, and if we add 1 on both sides, it's also remains true, so k plus 1 will be greater than 1 plus log to the base 2 of k. But we need it to be greater than log to the base 2 of k plus 1. And it is given clearly that we should use the result from A. And you can see that from A, 1 plus log to the base 2 of k is greater or equal than log to the base 2 of k plus 1. Then we can conclude that k plus 1 is greater than log to the base 2 of k plus 1. Something is greater than something, but this something is greater than this log. Definitely this is greater than this log. It's like x is greater than b, and b is greater or equal than 5, so we can conclude that x is greater than 5. Hence true for n is k plus 1. And conclusion: if true for n is k, true for n is k plus 1. Since true for n is 1, true for any n is positive integer. And that's all for this question.